Okay, in this video we're going to be looking at question 12 from the WJC Additional Maths paper from June 2014. So this is a differentiation question to start off with, is finding the second derivative of this expression. That means we're going to have to differentiate it twice. So remembering our basic differentiation that we know at the moment is that if we had an expression of y equals x to the power of n, then my derivative can be written as n x to the n minus 1. So the power comes out in front, and then the power drops by 1. If this is multiplied by something, so if we had something like 4x to the n, or in our case we have 2x to the 6, well then the derivative is going to be whatever that value is multiplied by the derivative of the x to the n. So if we had y equals 2x to the 6 plus 3x, then my dy by dx, so my first derivative, is going to be, well, let's have a look. 2x to the 6 will become 2 times the derivative of x to the 6, which is 6x to the 5, which is 12x to the 5. And 3x becomes 3 times the derivative of x, which is 1. So that just becomes plus 3. And the second derivative, we're going to differentiate that expression again. So the first one we have is 12x to the 5. That becomes 12 times 5x to the 4, which is 60x to the 4. And the plus 3, any constant differentiates to 0. Okay, 12b is an integral question. So the first thing we always check when we integrate is if it's an integratable form, if it's in this x to the n format, which they all are, which is great. So just a reminder that if I wanted to integrate x to the n with respect to x, then it's x to the n plus 1, so raise the power by 1 and divide by the new power. Now you can either write it as divide by n plus 1, or I like to write it as a product of a fraction. So I like to write it as 1 over n plus 1 times x to the n plus 1. Similarly to the derivatives, if that is multiplied by a value, well then this whole side gets multiplied by the value, so we end up with a over n plus 1. Now, if you decide to write it as a division, that's absolutely fine. No problem at all. It's just a matter of personal preference. Okay, so let's see what we have. The first term is 3x to the 4. So that will integrate to 3 times the integral of x to the 4, which is x to the 5, and divide by 5, so 1/5 x to the 5. So we get 3 lots of a fifth, so that's 3/5 x to the 5. Okay, then we have plus 6x. That will integrate to 6 times the integral of x, which is half x squared, so x squared over 2. 6 times a half is 3, so that's going to be plus 3x squared. The next one is going to be 8 times by, so the derivative of, the integral of x to the negative 2. So we get x, we raise the power by 1, and then multiply that by 1 over that value, or divide by that power. So we end up with 8 multiplied by 1, which is 8, divided by negative 1 is negative 8, x to the negative 1. So negative 8 x to the negative 1. And don't forget to always put a constant of integration when we have an integral that doesn't have any limits involved. And C, we have an integral that does involve limits. So we should technically have brackets around there. First thing I'm going to do is to do my integration. So they're both in integratable form, which is perfect. So 4x will integrate to 4 times by the integral of x is x squared divided by 2. So 4 halves are 2, so we get 2x squared. And then plus 1 will integrate to, so any constant integrates to that amount of x's. So 1x or just x. So plus x. And that is between 2 and 5. So I'm going to substitute my 5 in first. So I get 2 lots of 5 squared plus 5. And from that, I'm going to subtract 2 lots of 2 squared plus 2. I'll work out each bracket individually. So I get 2 lots of 5 squared plus 5 is 55. Minus 2 lots of 2 squared plus 2 is 10. So we end up with an answer of 45.